All right, Unit 4 review guide. First question, difference quotient. So you want to plug in x plus h everywhere. What's that? Okay, you want to plug in x plus h everywhere you see an x. So 4x plus h to the third minus 2x plus h quantity squared plus 3x plus h plus 5 minus, I don't have room, minus the original. Divide everything by h. Okay, so for the first part, you want to do 4x plus h, x plus h, x plus h. This is usually the hardest part, so you underline the first two. That gives me x squared plus 2xh plus h squared. Multiply that by x plus h, so we run the x through it, we run the h through it. So this is x to the third plus 2x squared h plus xh squared. Run the h through everything is plus x squared h plus 2x h squared plus h to the third. Can we combine anything? I see x to the third. What do we have? 3x squared h plus 3xh squared plus h to the third. Distribute the 4 from up here. So 4x to the third plus 12x squared h plus 12x h squared plus 4h to the third. So that's just the cubic term. You guys want me to keep going? Okay, so I need to do the quadratic term. So we have, let's recopy here. So we have 4x to the third plus 12x squared h plus 12xh squared plus 4h to the third. The quadratic term now is going to be minus 2 times x plus h quantity squared, and the next one's plus 3x plus h plus 5. We still have the original after that. So the quadratic term is going to be what? Minus 2 times x squared plus 2xh plus h squared. So minus 2x squared minus 4xh minus 2h squared. Over here, plus 3x plus 3h plus 5. We still got to get the original in there, right? So let's see how small I can write. 4x to the third plus 12x squared h plus 12xh squared plus 4h to the third minus 2x squared minus 4xh minus 2h squared plus, this isn't coming out much smaller, is it? Plus 3h plus 5. Okay, minus the original, which means I'm going to run a negative symbol through it, right? So minus 4x to the third, double negative, so plus 2x squared minus 3x minus 5. All of that's over h. All right, help me find the canceling. What are we canceling? 4x to the third and 4x to the third. 2x squared and 2x squared. 5 and 5. 3x and 3x. Typically anything that doesn't have an h should cancel, right? Is that everything? So we have 12x squared h plus 12xh squared plus 4h to the third minus 4xh minus 2h squared plus 3h all over h. So from the top we're going to pull out an h. So if I pull the h out from the top, what's that going to leave me? 12x squared plus 12xh plus 4h squared minus 4x minus 2h plus 3. These cancel out, right? And I'm going to let h be equal to 0. So that gets rid of that one, and that one. And what does that leave us for an answer? 12x squared minus 4x plus 3. Sound good? Okay. That took 5 minutes, yeah. So. Okay, number 9 says that if 3 and 4 minus I are zeros, or their roots, what else do I know has to be a root? The conjugate for plus I must be a root. So it says, given these roots, work backwards to find the original polynomial. So if I want to work backwards, I know that 3 was originally x minus 3. I know 4 minus I was x minus 4 minus I. And I know the other one was x minus 4 plus I. Make sense? Okay, so I want to underline those two. And I want to FOIL. So first times first is x squared. The outer is x times the outer part over here, and it's a positive x times a negative quantity. So it's a minus x times 4 plus I. For the inner, it's the 2 in the middle. Positive x times a negative quantity. A positive times a negative is a negative. What do I have? X times 4 minus I. And last times last is a negative times a negative, which is a positive. And I'm just going to write the quantities out that are being multiplied. 4 minus I, 4 plus I. Now we're going to go to the next line. We're going to distribute. So I have x squared. X times 4, it's a negative x. So negative 4x minus xi minus 4x, negative, negative, double negative, plus xi. Over here, we're going to FOIL. First times first is 16. The outer and the inner cancel. You'd have plus 4i minus 4i. And last times last gives me negative I squared. And I squared is negative 1, so it's minus 1, which is really plus 1. So when I go to my next line, x squared minus 4x is minus 8x. Negative xi plus xi cancels, plus 17. Now we bring down the x minus 3. So everything by x, everything by negative 3. If I do everything by x, I have x to the third minus 8x squared plus 17x minus 3x squared plus 24x minus 51. So this is x to the third minus 11x squared. 17 and 24 is what? 41 minus 51. This is your original equation. Then it says to prove that we did this correctly, so we want to use the longer method, right? The rational zero theorem, factors of the back over factors of the front. So there's a couple ways to look at this. If I'm looking at this as, now here's my equation, and I want to prove my zeros are correct. Well, they gave me the zeros, right? These were my zeros, right? Here, here, and here. I want to prove that I did this correctly. So factors of 51 over factors of 1. How can I kind of take a shortcut here? What do I know has to be the correct zero? It has to be what? If I did it correctly, it has to be 3 because they give me the zeros, right? So it's not going to be 4 minus I or 4 plus I. So for my box number, I'm going to start with 3. And again, if you didn't trust that, you could use your calculator, graph it, and see that 3 was a 0. What are my coefficients? 1, negative 11, 41, negative 51. Bring down the 1, multiply, add, multiply, add, multiply, add. Worked out even. That's a good sign. So this is 1x squared minus 8x plus 17. I'm going to set it equal to 0. And I want to solve this now, find its roots. I need to use the quadratic formula. So let's make a box off to the side. A is 1, B is negative 8, C is 17. So what do we know here? Negative B would be 8 plus or minus the square root of b squared minus 4ac all over 2 times a. Okay, so this is 8 plus or minus the square root of 64 minus 4 times 1 times 17 is 68 all over 2. So this is 8 plus or minus the square root of negative 4 over 2. And what is the square root of negative 4? 2i. So this is 8 plus or minus 2i over 2, all divisible by 2. So this is 4 plus or minus I. So what are my zeros? 4 plus I, 4 minus I, and 3, which is, back from the beginning of the problem, what we wanted them to be. Any questions on that? Good? Okay, so they give us an equation. It's a polynomial, x to the third plus 2x squared minus 4x minus 6. They ask for a whole bunch of things. First one, the easiest one to start with, is what is complex? Complex is the combination of real plus imaginary. So whatever your degree is how many complex answers you have. So I have 3 complex answers. And again, complex is the combination of real plus imaginary. What do I know about imaginaries? They occur in groups of 2, right? They occur in conjugate pairs. So as far as real and imaginary go, I could have 3 reals, and if I have 3 reals, how many imaginaries would I have? 0, right? Because I have a total of 3 answers, so 0 imaginaries. Can I have 1 imaginary? No. I could have 2 imaginaries, though. If I have 2 imaginaries, how many reals do I have? 1. Can I have 3 imaginaries? No, because they occur in groups of 2. Can I have 4 imaginaries? No, because I have a total of how many answers? Okay, so I wrote all the combinations out.
What happens if you had a degree of 4?
If I had a degree of 4?
Yeah. Would you then be able to have 3 imaginaries?
So let's go off to the side here. If I had a complex of 4, what would I have? I could do 0 reals and 4 imaginaries. I could do 2 imaginaries and 2 real, or I could do 0 imaginary and 4 real. But the imaginaries always occur in groups of 2, right? So the easiest way to do it is write out all your possibles for your imaginaries and then fill in the gaps with the real. Possible rational roots, you already know that. Factors of the back over factors of the front. Zeros, you know how to find them, right? You go through, do synthetic division, do all the work, or you could use your calculator and just trace them out. Sound good? Okay. What's that? You could try the factoring method, you could try the longer method, factors of the back over the front, and then do your synthetic division and then solve the quadratic. Or in this case, it's not giving you any direction on how to find the zeros. You could do those two. You could use your calculator and graph them out. The ones where you have to do it a specific way, it tells you the directions. Okay, the polynomial inequality problem. So we want to get everything pulled to the left. So x to the third plus x squared minus 4x. Excuse me?
You want to go the opposite way, or do you want to
Keep the leading term positive. Okay, so it's greater than 0. So I pulled everything to the left, right? Pulled that one over, pulled that one over, pulled that one over. When it's greater than 0, what am I looking for? I want it to be looking for positive. I have 4 terms, so I can factor these by grouping. Underline the first and the second pair. From the first pair, I can pull out x squared, leaves me x plus 1. From the second pair, I can pull out a negative 4, leaves me an x plus 1. Set it equal to 0 now. So I have x squared minus 4 and x plus 1. Remember, the x squared minus 4 was pulled out from these numbers here on the outside. I can refactor into x plus 2, x minus 2, x plus 1. So my zeros are negative 2, 2, and negative 1. And then you want to graph those on a number line. These are now your boundaries. So if I make a number line, I have a 0 at -2, I have 1 at -1, and I have 1 at 2. So how many boundaries, how many regions did I create here? So we have 4, right? So I want to plug in test values on all sides of these. So over here, I'd probably want to plug in, we'll write them in red, what we're going to plug in. Plug in -3, plug in -1.5, plug in 0, plug in 3. And I'm looking for each case to see if the answer is positive or negative, correct? So let's start with the 0, that's always the easy one. I'm plugging it into what? What am I plugging it into? I'm going back to the original problem, right? Up here, after we've set it all to 0. So right here, circled in red, that's what we're plugging into, right? So if I plug in 0, what do I get? 0, 0, more 0, negative. So this boundary is negative. If I plug in 3, 3 squared is 27, and 9 is 36. Minus minus, it's still going to be positive. If I plug in -1.5, you're probably going to want your calculator for that one. -1.5 times -1.5 is 2.25. 2.25 times 1.5. Somebody. 3.3. I did the math last period on this one. It's positive. So you go through, use your calculator, plug them all in. It'd be positive. Go through on this one. It ends up giving you a negative. Okay. So now I have 2 regions of each. I'm looking for the ones that are positive. Taylor, question?
Do you mean positive as in the answer is positive, or do you mean
I mean positive boundary. I mean,
zero?
well, the positive is greater than 0, but I mean as far as
I mean, like, no, zero.
I'm looking for the positive boundaries, so I'm looking for here to here, and then over here and above.
So, like, negative, like, it's not correct because a negative number would be greater than zero.
Yeah, exactly. So if I plug in, so in this boundary in here, any number I plug in is going to satisfy this inequality, meaning if I plugged it in, it would give me something greater than 0. Over here, anything I plug in is also going to give me something greater than 0. If I plug in something between -1 and 2, so for example 0, what do I get? I get a negative answer, right? Which means it doesn't satisfy the inequality because the inequality is set up to be greater than 0. So these are the boundaries where the inequality would then be true. Question?
So because it's you're looking for the positive, you do the parentheses, not like the box.
The squared off one?
Yeah.
Yeah, if it says or equal to,
Oh.
that's when you so in other words, if it was an or equal to one, then the -1 and the -2 would be included in your answer, meaning it would also give you what you were looking for because it could be or equal to 0.
Okay.
All good? Okay. Number 6. Number 6. Guys, recording, it's on. And we're dividing long division by x plus 3. So the question you ask yourself is x times what gives me x squared? And that answer is x. Then you multiply. X times x is x squared. X times 3 is 3x. We subtract. That goes away. Leaves me 7x. I bring down my 21. X times what is 7x? 7. Multiply, and that gives me 7x plus 21. I subtract. I have no remainder. And this one asks you to prove by foiling. So to prove by foiling, I say x plus 3 times x plus 7. Foil that out. I should get what's underneath here. So x squared plus 7x plus 3x plus 21, combine the middle, x squared plus 10x plus 21, and checks out. Okay, number 7 says divide synthetically, so I'm dividing this by x plus 2. So if we're doing synthetic, the number in the box is going to be -2. Bring down the coefficients 5. Now what do you have to do between this? There's no quadratic term, so I need to represent that with a 0. 6, 8, bring down the 5, multiply, add, multiply, add, multiply, add, drop the degree by 1, so what do we end up with? 5x squared minus 10x plus 26, remainder 44, negative 44. So we want to prove this. It says use the remainder theorem. Remainder theorem tells me to do what? Take the number that's in the box and evaluate this. Oh, I'm sorry, I'm looking at 8 by foiling. Okay, so we want to x plus 2 times 5x squared minus 10x plus 26. Now when you're done, you want to add the remainder, and in this case it's a negative 44, so you're really subtracting it. So run the x through it. What do we get? X times 5x squared is 5x to the third. Keep going. Keep going. Now run the 2 through it. So this is 5x to the third. Negative 10x squared and a positive 10x squared cancel, which is good because there was no quadratic term up here to begin with. Plus 26x minus 20x is plus 6x. And then I have plus 52, but then it says, remember we're subtracting that from the remainder, so 52 minus 44 is plus 8. So there's what I got. And that's what I should have got. Number 8, what do they give us here? 2x to the third plus 2x squared plus 3x plus 5. It says do this any which way you want, so I would assume you would prefer synthetic division, right? So the number that goes in the box is negative 1, 2, 2, 3, 5. So bring down the 2, multiply, add, multiply, add, multiply, add. So what do we get for an answer? 2x squared plus 3, remainder 2. This one we prove using the remainder theorem. Remainder theorem says this part up here, whatever zeroes it out, also known as the number in the box, plug it in to your original equation, and that result should be your remainder. So let's try it. So we're going to do 2 something to the third plus 2 something squared plus 3 something plus 5, and my something for all of these cases is negative 1. So doing some math, negative 1 to the third is negative 1. Negative 1 times 2 is negative 2. Negative 1 squared is 1. 1 times 2 is 2. Negative 2 and 2, those cancel. 3 times negative 1 is negative 3. And negative 3 plus 5 is 2, which is the remainder that I got in the first place. Okay. Okay, intermediate value theorem had 2 statements and 1 result, right? So let's draw a picture first. So here's my graph. If I have a point down here, we'll call this one f of a, and I have a point up here, f of b, and I connect the line. So what all did I just state here? What's my first rule? Something positive and something negative. So if I have something positive and something negative, and these two things are, I'm sorry, what? No, as long as something's positive and something's negative, going above and below x. And what's the other key point here? That these two things are, the line between them is continuous. Means you never lift your pencil off, so there's no gaps, no nothing between them. If something's below the x-axis and something's above it, meaning positive and negative, and it's a continuous line, then you're guaranteed what result?
0.
A 0 exists, and we call that f of c, so then you would highlight that and say this is f of c, and that's equal to 0. Make sense? So then in addition to that, the next problem says, show that a 0 exists between, so they give you an equation, f of x is equal to x squared plus 6x plus 5. It says show that a 0 exists between them, between 3 and 4. So if I want to show that a 0 exists, I'm assuming it's continuous, we're allowed to make that assumption. I want to plug in 3, and I want to plug in 4. And if a 0 exists between them, what do I know has to have happened? One of them needs to be positive, and the other one needs to be negative. So in other words, if here's 3 and here's 4, if I plug in 3 and get something up here, and plug in 4 and get something down there, and I know there's a continuous line between them, I know I'm good. If I did the same thing, here's 3 and here's 4, and they were both positive or they were both negative, well then I don't have a 0. So if one is positive and the other one's the other, that's how you know it'll cross. Good? Turning points. Shh, guys, video's on. Turning points. What do we know? Whatever my degree is, if the degree is n, let's say degree is equal to n minus 1 is equal to turning points. Example given. If I said y equals x squared, my degree is 2, right? 1 less than 2 is 1. Should make sense. If this is my quadratic, how many turning points does it have? 1. Turning point means it's going from decreasing to increasing. It's changing its direction. So again, turning points. Take 1 away from the degree. That's how many turning points you got.
From the first degree, right?
From the degree. So the degree is the biggest exponent you have. Okay, we want to factor, and in this case, this is the difference of perfect cube roots. So there's a blueprint that goes along with this. So our blueprint is a to the third, and this is a difference, so minus b to the third. The blueprint says that's equal to a squared, ab, b squared, and it's a difference problem. In the difference ones, it's minus, plus, plus. So the problem they give us up here, this part right here, this is the a to the third minus b to the third. Okay. So if I have a to the third and I want a, how do I go from a to the third to a? First off, I like to put my symbols in because they never change no matter what. But if I'm going to go from a to the third to a, I take the cube root. Good. So the cube root of 8 is 2, and the cube root of x to the third is x to the third is x, right? And I go to the other one, b to the third to b, the cube root of 125 is 5. Now it says I want a squared. Well, I know a is 2x, so a squared means square my 2x and get 4x squared. In the middle, it says I want ab. Well, I know a, I know b, it wants me to take a times b. Symbols are irrelevant here because we already have them from the blueprint. A times b, 2x times 5, 10x. Last one's b squared. Well, I know what b is, so b squared is 25. That is your answer. Now, the only thing that changes in this, if you did a sum problem, so if it was an a to the third plus b to the third, it's the same exact thing, except the only thing that changes is your symbols would go plus, minus, plus. Make sense? Okay. Actually, before I stop this, we'll do one more because there was a question last period. So for the last one, 3x squared minus 18x. This is a factoring problem, but not in the way you normally think of it as, because the normal factor methods don't apply, so we just pull out what they have in common, right? So this one I can pull out a 3 and an x, leaves me with x minus 6. If this was a solving problem, you'd set it equal to 0, and then you'd have 3x is equal to 0, x minus 6 is equal to 0, so x is equal to 0, x is equal to 6, and we're all done. Any other questions on the packet you want me to try again? All good? Okay.